Hi, welcome to the Calculus 3 assignment practice series. And we are in the unit vector calculus. And today we're going to take a look at our homework assignment number 3, which related to our lecture number 3, vector fields. Okay. And let's take a look at what type of the problems are going to be on this assignment worksheets. And in fact, this assignment worksheet is pretty easy if you be able to use the software to help you. Okay, let's take a look at our assignments here. Let me share that. Okay, so the first set of the problems here. So it's telling you, so if you have okay, so it's telling you if you have a set of the vector fields here, and they want you to sketch the graph. Okay, so sketch the graph of the vector field and choose your own points here. And in here, instead of doing by hand, I did a few by using the calc CALC plot 3D, like we see that in our lecture series. I use this software quite frequently. So in here, you'll be able to see, okay, so you'll be able to see what is the, what is the vector field looks like. So I choose the few kind of special. So for this ones here, this vector field, the scalar components here is 0.3 and negative 0.4 here. That means whenever the point you choose, right? Because so if you choose, you start from this point. Okay, so then the value 0.3 negative 0.4 is fixed. So you do like a 0.3 here, you go to 0.4 here. So you will get a vector go this direction. All right. So that's why for every points, right? So because they have the same value, so the vectors, so what happens here, they're all going to be parallel and they're going to the same direction. So that's what is the output if you use a calcplot 3D. So that's what is the vector field. But I just want to make sure you know if they all have a constant field, what's that mean? Right, that means they're all parallel, they have the same length. See here, the size of the vector, they are all the same because they are the fixed lengths here. Okay, so now also the next one I want to take a look is the problem number 7 here. So for the problem number 7, for this vector field, I only have I and it's 1. So that means when you try to plot it, see, this is what you have because that means it's all parallel to what the x-axis and what they all have the same length is equal to 1 for the different for the same direction because they don't have an x, y, they don't have y and the z or the j and the k components here, right? So this is what I want to show you, these ones here. And then the other one I want to show you is on the R3s here. So R3, this one's here, this is I and the K. So you have the I components, the K components, you don't have the J components. So that's why also because all these components here is a constant. So did you see here the vector, they all parallel along the Y kind of the parallels this way. So the y, because there's no y's here, right? And then the length of each vector is all the same. That's what is the R3 vector field looks like. Like I said, you can try to choose the point by hands and scratch, sketch that, or you can just use the software, which I think is way more easier and also give you better visions here, right? Okay, so from the number 11 to number 14 here, so they want you to match the, okay, they want you to match the vector field with the graphs here. So in here, that's, what you can do is you put it into the, the software, or you can plot a few points. So what I did here, so for the first graph, so I matched with number what? It's number 13. So it's this one here. So for the second graph, I matched with number 14 here. It's kind of like a cosine. They have like the certain kind of circle, like the periodical patterns there. Number 3 is here. I matched with number 11 here, and the number 4 here. I matched with number what? Number 12 here. Like I said, you can plug each one into the software and you can see what the pattern looks like. So the same way for 15 to 18, you can just plug this one with the R3, then see how the vector field looks like. Then you'll be able to identify it. Okay, so like number 21, we say we want to find the gradient field, right? So we talk about the gradient, so will just be the partials, right? So this will be what? So the x here, so it will be y cosine xy, then what? Then the chain rule, right? X is y, so I have what here? I have y squared cosine xy, right? All right. So now the same, the partial at y, I have a product rule, so I have a sine xy plus y sine, so y, the sine derivative will be what? Will be cosines, right? So this will be cosine xy, then chain rule times x. So this is x. So I know my vector field, so del f, so I can write it as the gradient vector fields. So what is my gradient vector field? Will be the y squared cosine xy. This is my I components, and the plus, so this is sine xy plus y cosine xy cosine. Oh, I better write it. Okay, so here, okay. So this will be plus xy cosine xy. So this is my j components, right? So just be very careful about your derivative and applying all the rules you learned, the derivatives here. Okay, so we can try to do one more for the R3. So this one's here, this is f of x will just be the natural log of y minus 2z's, right? Then f of y will just be what? Will be x over natural log of y minus 2z. Chain rule is 1. Then the f of z will just be what? X, this is the natural log y minus 2z. So this is 2z's, right? Okay, so it's 1 minus 2z, then the chain rule, so it's negative 2. Okay, so now I can say my del f here will just be what is natural log y minus 2z. This is my I component, plus this is x. This is natural log y minus 2z. This is my j components. Then plus negative 2x natural log y minus 2z. This is what? This is my k components. It's pretty straightforward, this first assignment about vector field. Okay, so now the last ones here, we need to be careful. Let's say the match the function with the plot of their gradient field. So you still can use the software, but the input here, the first things you need to find the gradient vector fields, right? So for these ones here, the gradient, so del f, so the one you input into the software will be what is 2x, 2y, correct? Okay, so you just need to be careful. So it's 2x, 2y. So if you plot it, then you will find out this is the ones, right? So this is number 29. You will get a graph like this. Okay, so you can try to do the others, but first make sure you need to get the del f, the gradient vectors here, right? All right, so this is a pretty simple assignment, and basically try to emphasize what is the gradient, what is the vector field, and how do you graph it, or how do you use the software to graph it. Okay, that's it. Okay, and I hope this help you to do this assignment. Okay, talk to you later. Bye-bye.